Thank you all very, very much. Extraordinarily interesting and helpful. I'm looking at my colleagues about a list, so I've got Alta. I'm going to take first priority here since I deferred last session. Anyone else? VOMC? And others can speak up, of course. So, sorry. We're going to go until 12:15, at which time we will break for lunch, which will go until 1. Is that going to work? And the challenge was we've got Nick Hopwood joining us by WebEx, but apparently that will work for him. So we're pushing back a half hour. So we will break at 12:15, 45 minutes for lunch. That will give everybody time to go upstairs who needs to the cafeteria, and we'll reconvene at 1. Okay. And our colleagues on the phone probably will let us know if they want to speak up too. So let me start the discussion. And I think I know John Harris's answer because he sort of addressed it. But let me ask the others of you, and maybe John too. There seem to be at least 2 things, probably more, going on in the prohibition of germline genetic modification. One is what changes we introduce, but the other is the risk of going forward. And all of you, I think, except maybe for John Harris, spoke to the former, to the what it is we're changing rather than the risk of doing this. Now, the charge to this committee really involves both, but I'd love to hear you opine on the question of when it's safe enough to go forward. John put it that way, John Harris put it that way, and we heard what he thinks, but that's a really critical question for how we think about this in the context of FDA approval of a clinical trial in this context. So that's my question to you all, and we can take it. You want to start, Annalene, and just move our way down?
Well, I think it's often mentioned that the risk of germline modification are intergenerational, but they are only intergenerational if the next generation reproduces. So I think we should not overestimate those risks because they are only there for this particular child. But that's the same, I think, as for other assisted reproductive technologies. So it's only if the resulting child will think about reproducing, then there is an additional risk. And for mitochondrial DNA mutation, because of the maternal transmission, one could consider in first human applications to only transfer male embryos, because then you don't have the risk of carryover and of transmitting it to further generations. So that could be a point of discussion.
Thank you. Very helpful. Marcy.
You're thinking about the safety risks and what's safe enough in terms of safety.
And I should have said the uncertainty, which is obviously a big part of the concerns about risk and safety.
On the safety front, I've been really struck at how the evidence of safety really doesn't seem to me, and it didn't seem to the FDA Advisory Committee panel to be there at this point. And there are a few monkeys, but with the technique that's being developed at Newcastle, there are no non-human primates. With the technique that was used for the monkeys, there were abnormalities in the human zygotes that were created. And I mean, if this was a drug we were talking about, I don't think 5 monkeys would cut it. So that's on the safety end. And there's an accumulating literature, which actually we've drawn up a list that I would be happy to share with the committee. I would like to share with the committee of scientists who are talking about risks of various kinds because of the mismatch, the epigenetic concerns, the physical manipulations, and so on. On the social side, I think, we have a harder time thinking about the social risks and the unknowns, but I would just say that, when we know that science not only lightens our burden, but also creates new burdens. And when you think about climate change, for example, when whoever took the first barrel of oil out of the ground could not have foreseen the consequences downstream of that. There was no way you would either be able to predict, lost luggage on airlines or disastrous climate change. But we do have an opportunity to look forward and think about what the social, the commercial, the economic consequences of allowing germline modification would be. And I think it's incumbent on us to do that.
John.
3 quick points. One is I do think it's important to think about social collective risk, which is kind of hard to do within the medical and bioethical models. Number 2 is that I think historically this concern about risk actually dovetailed quite nicely with this concern about nature, in that everyone wants things to be natural. I'm sure at lunch we'll eat all sorts of natural cereal bars and natural this and that. It's a very deeply ingrained concept, and I know nature can obviously be wrong, but people don't think of it that way. And so one way to avoid these risks for people has been to want things to be natural. And finally, I have been curious about this intergenerational risk, and I think I don't understand the science enough, but I do wonder what the situation, if it's possible to create problems 2 or 3 generations down the line that wouldn't emerge until 2 generations down the line, how this would actually be recalled. I mean, that part has always been unclear to me. Like, you would actually have to stop people from reproducing somehow 2 generations later. So if that is a scientific risk, and I will admit I don't understand that, you got to think about how socially you would actually stop people 2 generations down the line from reproducing. But again, I don't have the scientific background to know whether that's an issue.
John, yes.
I just add a couple of things. First, there is a sort of widespread illusion or delusion that any precautionary approach involves setting safety against danger. But we know that that just is not true. Just as justice delayed is justice denied, so therapy delayed is therapy denied. So we always have to think about the cost of allowing things to go on as they are, and a number of speakers have referred to that, as against the possible risks of things getting worse as the result of the introduction of a new technology. But it is not, as it were, cost-free getting worse. There are costs now in allowing people like some of the speakers we've heard today, the first one in particular, as it were, being forced to run that risk of producing children with dangerous diseases that could be remedied. Secondly, on the social risks, they can be overestimated. I knew Patrick Steptoe and Bob Edwards very well, the 2 people responsible for the birth of Louise Brown, the first test tube baby, and as a young lecturer, I invited Patrick Steptoe, just following the birth of Dolly, to come and speak at my university, the University of Manchester, and give a public lecture. And on the morning of the lecture, we first had to find a much bigger lecture theatre because the number of people wishing to come was enormous. And secondly, something unheard of in my university back in whenever that was, in the 70s, the chief of security came in and said, how are we going to protect the speaker? Because there was a huge public outcry against this unnatural piece of science. We now know, and it may be just moral luck as well as scientific luck, that that was a remarkably successful methodology with over 5 million healthy children born thus far as a result of that, and all of them, I hope, thanking Bob Edwards and Patrick Steptoe for having the bravery to push ahead. So we have to bear those sorts of considerations in mind as well.
Thank you. Alta and Vamsi and anyone else who wants to be on the list. Alta.
I agree. It was tremendously interesting and helpful, so thank you. As well as amusing. For that, I thank you as well. If I'm hearing correctly, key elements in why people think this is so interesting and essential has to do with both the nature of the change, whether it's good, bad, or indifferent, but also the way in which the multi-generational aspect of it kind of magnifies or amplifies those risks and benefits, right, which seems to up the ante in the conversation. So I wanted to ask you about 2 other technologies that at least are showing hints of having multi-generational effects in order to really drill down on that particular aspect. One is epigenetics, which we know has at least, mother-to-child effect, but there's some very intriguing research that shows hints that epigenetic changes might not be reversed it's not unclear if they're irreversible, but at least not reversed even across 3 or even 4 generations. And we've seen that suggested in some human observational stuff as well as in some animal work. The second is in the microbiome, which is everybody's new favorite thing to talk about. There, obviously, we're seeing now the notion that the microbiome is actually passed from mother to child, and if that child's microbiome stays substantially the same, would then again be passed to the next generation. So we've got epigenetic drugs already being developed and approved. We've got fecal transplants that are already being done. So we actually are seeing therapies that could have multi-generational effects. I want to have a better handle in my head about whether these are completely distinguishable or not, because it seems like germline is really focused on DNA, whether mitochondrial or nuclear, and these are two things that are not necessarily about DNA, but seem to have some similarities. And if these are okay, then why would not the transformation in the DNA also be okay? I'm just trying to, I love your charts, but I need a new set of cells and a new slide from you, John.
Can I try and
Sure.
one of the points that you made, and that is the epigenetic point. And I think the more we learn about genes, the more we know that they're not as influential as everybody thought that they were, at least not in terms of the nuclear genome. And distinctions, rather damaging distinctions, are often made between real parents, for that read genetic parents, and all sorts of unreal parents, like foster parents, adoptive parents, and so on. And a colleague of mine, Giuseppe Testa, in a paper with me, have proposed that perhaps we should think of abandoning that particular distinction and just talk about genetic parents and epigenetic parents. Because the non-genetic parents also have almost certainly epigenetic effects, as do a lot of other things in the environment as well. So I welcome lots of things that we're learning about epigenetics precisely because it is weakening what most scientists, certainly most geneticists, are coming to think of as being too deterministic a view of what you get from the nuclear genome.
I know we're going to talk, but if you're going to do that, then we also have to talk about our bacterial parents, because it's the bacterial,
Absolutely. No,
bacterial
absolutely.
genome that's in our microbiome, right? So we've now got many thousands of parents.
And also, of course, the other members of our family are ape ancestors, and before them are ape ancestors' ancestors.
I would just say, having thought about this for 30 seconds, I would say that if you truly had intergenerational change from modifying epigenetics, I think that, like all these things in the issue, there is an initial yuck factor, and there's like, oh, babies in a test tube, that's incredible kind of thing. That fades relatively fast in the public. I think what doesn't fade is the sort of, again, the goals, what you're intending to do, et cetera. So I don't think there would be a difference in people's mind between changing someone's genes by changing their epigenetics, however you would, put them up in a Finnish village above the Arctic zone and have their parents starve to death, but however this actually happened.
30 seconds.
Yeah, but I think that, there will be a strong yuck factor with fecal transplants, and then people would get over it.
Yeah, you've opened up a lot, as you often do, Alta. I would like to point to the contradiction, and of course none of us are ever 100% consistent, but on the one hand, I certainly welcome the idea that genes are not deterministic and we move away from reductionism, and that the developments in having to do with microbiomes and epigenetics help us do that. But on the other hand, I will note that a lot of the argument for moving forward with these techniques is based on the fact that genes are really, really important, and they're important for children, for parents who want children who are completely genetically related to them. So that's one thing. And the other thing is, I think it would take a while to tease this out completely, but I think that the social dynamics, the commercial dynamics that I worry about if we go forward with germline modifications are that they would not be able to be exercised. You would not have the power of technology and science being the power of one kind of person over another kind of person if we were talking about microbiomes and talking about epigenetics in the same way as that is true when we're talking about manipulating DNA, either in reality or in people's understanding. So, and I think those are both things we have to take seriously.
Well, I think it may be interesting in this context to have a look at the earlier discussion of the RUC about what is the definition of germline modification. And then they had for this PhD thesis, I had to look at the minutes and the discussions. And there was a huge discussion about whether it matters whether the germline modification is intentional or unintentional. So is it inadvertently changing the germline or not? And I think there may be some issues here also. And because people make many conscious or unconscious decisions about their children and their genomes. For example, there are studies from the children born just after World War II, and it's generations on. The mothers didn't have any food, so generations on that it has all kind of health effects and also other effects. And where we live, with whom we reproduce, is making a decision, also a genetic decision for your children. So I don't think that is the most interesting part. I think it's more about, does the intention matter? And I think it does in this case, as some previous speakers also said. I don't think germline modification should be the issue. I think the context and the goal should be what we should discuss.
Very interesting. Vamsi.
So I have a very specific question for all of the committee members, and that is there a relevant difference between editing a genome and replacing a genome?
Depends what you mean by relevant. Of course there are distinctions, and I think there's a wonderful phrase, and I can't remember where I got it, but I think it was from the American civil rights movement at some point, which is the phrase "eyes on the prize." You can't answer a question like that unless you've already decided what the prize is. In other words, what's important. And it may or may not be an important distinction, depending on what you're trying to achieve or what you're frightened of or any of those things. But I don't think, as it were, and other people have mentioned this as well, and it was also in Hugh Whittle's talk and in the Nuffield Council's report, what we should concentrate on is what the prize is. What do we want to achieve, and what are we frightened of achieving? And it doesn't matter whether the good results are achieved by germline or some other form of therapy, and the bad results. What matters is how likely those bad results are, and of what nature they are. We shouldn't, in other words, set up a sort of icon that no germline modification or no GM food in the supermarkets. And that is another completely irrational fear about GM foods, and the language that goes along with the fear of GM, the pollution of wild species and so forth, is an entirely tendentious language. And the issue for GM is, can we make crops that will grow in hostile environments, because we need to make those crops? And if we have to do that by GM, for God's sake, let's do it. And not search around for other less efficient ways simply because they don't involve genetic modification.
I think the distinction depends upon that final distinction I made in my presentation, which is an empirical question, and so a social psychologist could try to test this. But it's possible that people might perceive that this contribution from the third parent is sort of natural because it's complete, and you took an embryo apart, but you didn't necessarily invent it. And then if that's the case, then that would be a moral distinction. I think it's empirical perception, and perhaps people later will be able to talk about what people think about embryos, whether or not that's a divide that people would hold.
Yeah, I would see this, I think, differently from either of those. From a strictly biological standpoint, it may turn out to be that the mitochondrial manipulations are more extreme than the gene editing, depending on how precision gene editing turns out to be. So that would go to the questions about physical safety. From the social standpoint, I think modifying nuclear DNA is far more extreme and is far more likely to lead to the socially dangerous consequences that are what underlies a lot of the concern about and prohibitions against human germline modification. Because with the gene editing tools, in theory, and early days, we don't know in practice, there you could modify, you could take out, put in multiple genes, multiple sequences of genes, take them from another person, take them from another animal. All kinds of proposals have been made, including for all those things I just mentioned by scientists from prestigious institutions who were speaking speculatively, but with some enthusiasm about those prospects.
Well, I think I have two answers. If you would refer to editing or replacing the genome, and you're talking about the same entity, I'm not sure whether there is a difference. As I also said, I'm not sure whether, I don't believe in a dichotomy between changing the mitochondrial genome and the nuclear genome. So then I would be inclined to say not really from an ethical perspective. If you would refer to different entities, so between editing the genome or replacing the genome, so for example the difference between PGD and mitochondrial donation, then interesting enough, some people, also some critics, might be even more enthusiastic about mitochondrial replacement than about PGD, because PGD is selective, and in this case, it may fit better within the goals of medicine, the curing goals of medicine. So that's interesting that people embrace PGD, while if this would be safe and effective, I think it would also perhaps even better fit within the goals of medicine.
So among anyone else on the, well, we want the people on the phone to also have a chance, but while we poll them, Annalene, I think you mentioned in your remarks that one approach to controls might be to limit the implantation of embryos to male embryos. So I wonder if the four of you could speak to whether you think that's appropriate, and if so, why, or if not, why not?
Well, we should be reluctant to do that. It doesn't mean that it would ultimately not be a way to see whether other problems occur or not. But we should be reluctant to do it, partly just because of not an irrational prejudice against forms of discrimination, but a prejudice against them that doesn't need usually to be defended. And I don't think there's enough evidence to be worried about mitochondrial transfer from the safety angle to justify that particular step. But that may be a further down the road solution if there does seem to be a problem. But I'd be very reluctant to go that way now, but simply because I don't think that the dangers are specific or real enough yet to be worried about it. They're the sort of penumbra of dangers you always have with a new technology of whatever sort, and you never know what the long-term effects are, whatever the technology is, and that spectre is always raised. But the reports that we've looked at in the UK about this, which is why we have approved it in the UK, and why you'll hear from Turnbull tomorrow, I think it is, about the scrutiny that the technique he's developed has had, give us, I think, enough optimism to think that we don't need to go down that route.
I would say that, that it has to be decided whether or not the goal is to provide this for everybody. And then if so, I don't know enough about the safety issues to comment upon this, but if there is a high enough concern that there might be some multi-generational problems, then I think that would be sort of a reasonably safe step to go. But I think you do first have to decide that if this works and there does seem to be any problems, then we will go forward with this for everybody.
Just add one thing, sorry. The alternative, often people with this disease will want to have genetically related children and will go ahead to have those children with the known result that there will be defects passed on in the genome. So we're not necessarily setting this against an entirely safe alternative. It is not as if reproductive damage will not get into the genome. It just won't get into the genome through this technology, and it may never. So it's not as if everybody who wants children who are affected by these diseases is going to abjure sexual reproduction as an alternative, and nobody is thinking of stopping them, I'm very pleased to say.
Interesting question. my own and my colleagues' or opposition to approving this technique is based really on two things. It's based on the safety considerations and the social considerations that I've alluded to. From a safety point of view, there are some papers that suggest that actually would be additional risk to male offspring, and I can send you those. So that I don't know how to evaluate that, but it needs to be evaluated. And from a social point of view, the idea of opening the door, paving the way for further germline modification techniques, that I don't think limiting it to boys would ameliorate or mitigate those concerns. So,
well, I suggested it with a reason. So, well, I think this form of sex selection would be some kind of a stretching of the medical model, because it would be for intergenerational health risks. But I'm not sure what I could say that it's overstretching the model. But I do think that there are some points of attention. First of all, I'm not sure whether it would be feasible, because if mitochondrial donation would be still an inefficient technique, I can imagine that you're not throwing away embryos after this procedure only because they are of the female sex. So I think there are some feasibility questions. And I also think that there's a difference between offering this to people, or if they ask it, to reduce risks as much as possible, than thinking about it rather than offering it as a coercive offer. So I do not think that it should be offered as a coercive offer, so that the first trials will only transfer males. But if some parents are well informed and would ask, if you have some embryos made by this procedure, we prefer to first transfer male embryos, I don't think that's wrong.
Very helpful. It's 12:15, I'm being told. It is. Okay, we obviously could go on for a much longer time, and we will, but after lunch. So let's break. Thank you all, the four panelists, and like I said earlier, we hope you can stay with us and maybe contribute later. So we will reconvene at 1 o'clock sharp, so please be here a little bit before so we can start the panel at that time.